So welcome to another episode of Gearbox Labs. Today we are going to learn about servos, flex sensors, and force sensors. This is an excellent project for robotics. So the first thing we are going to do here is changing the name of our project. Going to the top left, this is gonna be flex sensors and force sensors. Those are the two most important sensors that we are going to be using. So the first thing is programming these two with Arduino Uno. So we are bringing Arduino Uno. We can change here to all, so we can see all the components that Tinkercad has. Also, if we don't know the function of each, we have the option at the top right. By switching to grid view, we can see a little description of every component and every sensor. So the next thing is going to be our breadboard. In this case, we are going to use a large breadboard since there are a few components that we are going to use here. All right, there we go. Our next is our servo. So we are going to use a micro servo. Then this micro servo is going to be controlled by flex sensor. So let's bring our flex sensor. Then force sensor. And our last are going to be 3 LEDs. So we will need for every LED a resistor. We are going to see values of these resistors and also the polarity of the LEDs. So here is one resistor per LED. And we can close the search area so we will have more space for our wiring. These components, they will use 5 volts and ground. So we are going to bring 5 volts from our microcontroller. So click and draw a cable to the red rail. This one is gonna be our connection to 5 volt, and it's always the positive side is marked as a red line. And if you see there the green pins, every pin is gonna be voltage, 5 volts. So we click on it. Then at the top left, we have the option for changing the color of our wire. In this case, let's change to red so we can identify the voltage in red. And for ground, which is next to, we are going to use blue. So let's click and draw a cable to the blue section or the cathode, which is here. In this section, we click and let's change to blue. So that way we have all these pins for ground and all these pins for 5 volts. Since we are going to have many wires, well, we already have the 2 rails ready for our sensors. So the next thing is bringing this servo to the left, and let's bring as well our flex sensor to the left. This one is gonna be placed, let's use letter G. If you see at the left, this one, letter G, is the column. I place the flex sensor on the G column, and then these columns are not connected. The ones that are connected are the numbers. At the bottom you will see that the breadboard is labeled with numbers. Those are the rows. In this case, for example, if I place this one, you will see that all this row is connected. All this row is connected. So that's why we are placing our flex sensor this way. Now for our LEDs, we need to check first thing, as I said, the value of our resistors. If we click on them, you will see that these ones are 1 kilo ohm. The number is too high. We need to change this number to 220 ohms. The characteristic of these resistors are gonna be 2 lines in red, 1 in brown. And we are going to do exactly the same with resistor 2 and resistor 3. So let's change to 220 ohms. So that way our LEDs are gonna work. It's a way to protect our LED with this flow of energy. Now, the next thing is checking the value or the polarity of our LED. In here, if we click at the left, we will see that this one is the cathode or the negative. This one is gonna be connected to the blue rail using the resistor. So basically the resistor connects the cathode with the cathode of our breadboard. We will see that in a few minutes. Now, these 3 LEDs, they have the same color. We are going to use 2 more colors. So how do we change the color of these LEDs? By clicking on the component, and then at the top right you will see here options. So the first one is gonna be changing to yellow, the second LED, and our third LED is gonna be green. So we look for green and change. So that way we have our 3 colors ready. The next thing is bringing our force sensor to the same column, which is column G. So we can put it in here. So now we are going to place the LEDs on the breadboard, and we are using the same column E. So we're bringing the first one, which is the red. So red is gonna be placed on column E, followed by yellow, and our third one is our green. So we have here our 3 LEDs. The next thing is looking for the cathode where the resistor is gonna be placed. So we are bringing our resistor that connects the cathode from the LED to the breadboard. The same for yellow and green. So that way we have our 3 LEDs ready. Then anode, which is the right side of our LED, and this is the connection to our Arduino microcontroller. We will program our LEDs that will work with actually the force sensor. So our green is gonna be the connection to the number 2. So we're going to look for connection number 2, and then click again to connect the cable. Now in here we change the color to green, so this one will match our LED. By clicking twice on the cable, we can actually bend and redesign the wire. So that is a good option, so we can see the numbers here. Our next one, which is yellow, looking for the same anode, and we are going to use the next pin on our Arduino microcontroller to connect yellow. So this one, click twice and just using the point, look for the way you are going to where you are going to place the cable, like that, and you have your second connection there. And our third LED is gonna be the number 4. So let's just connect this one to number 4 and change to red. So that way our 3 LEDs are ready. There are gonna be some other resistors that are needed for programming our force sensor and our flex sensor. So in the search area, we need to look for 2 more resistors, and these have different values. So we have to be careful when we connect the force sensor because they work with 1 kilo ohm resistors. So what we are going to do here is checking the first one, and this one is 1 kilo ohm. So this is the right sensor, right resistor, sorry, for our sensor. So what we are going to do here is bringing our resistor, and this is going to be placed, one of the pins placed on a column H. So this column H is going to be our first connection. Now at the top left, let's continue using the rotation icon here, and then let's bring again a resistor to column H like this. So it's gonna be a horizontal connection, and then we will continue working on this row, which is row 49, and from here is gonna be our pin for our Arduino. So let's get one of the pins, draw a cable that goes to the analog side of our microcontroller. So we look for the analog side, which is at the bottom, and then let's pick A number 1. So A number 1 is gonna be our connection for force sensor. We change this one to another color to identify the analog connection, and then let's click twice in here so we can bend and redesign the diagram. Then this side of our force sensor is going to be used for programming, while the other one, the second part of the resistor, is going to be our 5 volts. So we need to look for a connection in one of these pins, and let's draw a cable to 5 volts. So in this case, we have this rail. So this one is a rail for 5 volts. And just bend to redesign. So that way we have our resistor connected. For sensors, they need ground as well. So that's why we have a second pin here. So this one, we can add a cable from here all the way to our ground. Changing the color to blue to identify ground, and clicking twice on the cable to redesign the diagram. All right. So then our first part of the project is ready. The second one is the connection of the servo and flex sensor. We are going to do exactly the same type of connection with the flex sensor. This one needs a special connection, and we will continue using column H for the resistor. But in this case, this is gonna be a 10 kilo ohm resistor. So let's click on it and let's change to 10. This resistor usually has one line in brown, one in black, and another one in orange. And you can identify the 10 kilo ohm resistor. So let's bring this one to our column H, to the right side of our flex sensor. And we place one of the pins using again the same icon at the top left. Let's rotate our resistor and move this first pin to column H. So that way they are gonna be all in horizontal. So we will do basically the same, getting one cable from this column, which is I, and then from here we are going to look for a 0, which is the analog side of the microcontroller, and let's connect. This one is gonna be, let's look for yellow to identify the analog connection. Again, we click twice and redesign. So like that. Then the second part of the resistor has to be connected to 5 volts. So we are looking for G. From here, this column, we just draw a cable to the red rail for getting the voltage. Our last pin is gonna be the ground. So this type of sensors, they need as well voltage and ground. So let's just finish this diagram with a blue cable. Click twice to redesign the diagram. The last component is our servo. We have to be careful when we connect these servos. Again, they have polarity, and usually the cables are coming in orange, brown, and red. So the orange or yellow, you will see the difference in colors here. Those are going to be the signal or the connection to our Arduino. In this case, we need to look the signal or connection that comes from the servo to the microcontroller. But if you take a look here to the numbers that have a tilde next to every number, in case 9, 10, 11, or 3, 5, and 6, those are the connections, the special connections for our servo. So let's bring this signal first cable to the number 9. We're going to pick number 9, and this is the cable used for programming. I can match this one yellow for the flex sensor that is in yellow. So flex sensor is gonna be actually controlling our servo. All right, there. So we have our first connection. These servos need as well 5 volts, which is a red cable. So we are bringing one cable to 5 volts. And let's identify the color as red. In here, we can actually click again on the cable, so we can just stretch a little bit this side of the cable, so that way you can identify that this one is 5 volts. And the last one is our ground, is a brown cable. So let's bring this one to our blue rail. Bringing to the blue and just redesigning and changing to blue. So that way our diagram is ready. The next thing is gonna be, first thing is going to the top right section code, and then from here we are going to select text and continue. Since this one is a C++ language, so we will type some lines of code, and in here we erase the code that Tinkercad is giving us, and if we want to see our project working, at the top left there is another icon, so click on zoom to fit, and then we will be able to see the project. In here, the first part is adding the libraries and defining the sensor pins, the variables. So the first one is gonna be the connection to our servo. Those can be found in GitHub. So first thing is gonna be adding our include. Every time we add an include, that one is for a library. So servo.h. So in here, by adding // we can add comments. So this is our first step. Then we have to give then a name to our library. In here, just make sure that this one is capital. So let's change this to capital. Now next thing is bringing again the name of our library and give a name to this. So in this case can be my servo. So this name is the one that we're gonna be using in the rest of our code. Then we are going to use 3 more defines, and these ones are special words that we use for controlling the reading of our sensors, or all the data coming from the sensors. So define, we are going to use servo, another name, servo pin, and then in here we need to indicate the connection that we are using in our microcontroller. So in this case is number 9. The same is gonna be for our next sensor, which was the force sensor. So this one, we need to go back and see where we connect this one, and is the purple. So you take a look, there is connected to a number 1. Our last define goes to the flex sensor. So in here we have to indicate, which was the yellow, A0. So that way we have the 3 connections. Then we can go back to line number 4, // and just type comments, define sensor pins. So that way we can identify the parts of the code. The next thing are gonna be the int. Int is a variable that we use for reading whole numbers. In this case are gonna be numbers coming from the red LED. And in here we need to look for the connection of the red LED, which was number 4. So 4, semicolon. Every time we use a sentence like this with int, integer, and the name of the variable, a number, we need to close the sentence with a semicolon. And we are going to do exactly the same with the other 2 LEDs. Yellow, and yellow was number 3. and then the last one is our green. In number 2. So then we will continue with the variables that will hold the sensor values, which are lines 12 and 13 for flex sensor and for sensor. Also, we need to indicate the servo and the LED positions. So in here we have all related to that position and its variables. This is about the declaration of variables. Then we will have the first function, which is the void setup. In void setup, we need to indicate the speed of reading of the serial monitor. Since we are going to use this one, we need this line 22 for reading our serial monitor and all the data coming from the sensors. Then the next lines on the void setup are for starting all the sensors, all the LEDs, and these ones are the pin modes. Some sensors are gonna be inputs, which are constant, and the rest of the components, which are only on and off, the LEDs in this case, are outputs. This information is encapsulated in our void setup. The last function, which is the void loop, in here we basically indicate the function of our sensors. We start with a delay of 10 milliseconds, so we will give time the sensors to get the data and process it. In here, since we have analog connections, we need to use analog read for both sensors, force and flex. If we want to see the data, we need the data for programming our sensor for the conditional statements. This line 39 is very important. You will be able to see the readings coming from the sensor and to design your conditional statements according to your needs. As I did in here, from line 42 to 46, I'm using the force sensor value at 557, and then in here I program my LEDs, being the green LED in high or on. In this case, I'm using 3 conditional statements, and the last one is my flex sensor, the one that controls the servo. And basically here is one of the parts of the code that we use a lot for robotics, which is called mapping. Mapping uses as well analog read, and actually what it does, it matches the servo's readings and the flex sensor readings. In this case, the first one is maximum and minimum of the flex sensor, and the last 2 are the angles of the servo that goes from 0 to 180. And in here is just programming the position of the servo, going back to the original position or position 0 after moving the flex sensor back to the original position. So let's start the simulation at the top right. So when we do this, the first thing is, let's open the serial monitor so you will see the values coming from the flex and force sensors. So in here, if you click on the force sensor first, we are gonna start with the red. As soon as the flex sensor is changing values, the yellow will change to green and then going back to red. And in case of the flex sensor, we will see that the values are changing, and it moves the servo from 0 to 180 according to the mapping that we add there.